Hi guys, so today we will be presenting about separation of immiscible liquids of different densities presented by Group 5. Our group consists of 5 group members starting from Nur Muqdis bin Hamid, Muhammad Izzuddin bin Muhammad Fazli, Nur Anissa Nabilah binti Zakahirul, Nurul Anissa Ayuni binti Zakaria, and Nurul Jannah Balkis binti Muhammad Fauzi.
The separation of immiscible liquid with different density is a simple yet powerful technique used to isolate substance without chemical change. This method plays a key role in both laboratory analysis and large-scale industrial process, from product purification to environmental cleanup. Next, my group will be presenting about liquid decantation, a simple process to separate liquid of different density by carefully pouring the top layer into another container, used when two liquids don't mix, example oil floating on water. And lastly, centrifugation, a technique that uses rapid spinning to separate mixture by density. Heavy liquid move to the bottom, lighter stay on the top, common in lab and medicine manufacturing.
For the applications between laboratory versus industry, there will be 3 main focus that we will be discussing today. The first one is separation of essential oil and hydrosol using decantation. Next, separation of oil spill using decantation. And the last one is separation of immiscible liquids using centrifugation in pharmaceuticals.
So, the first one, I will explain to you about the separation of essential oil and hydrosol in cosmetic application. First, take a look at these two pictures shows the key differences between the essential oil and hydrosol. Their properties are different when essential oil has oil-soluble components, meanwhile, the hydrosol has the water-soluble components. So that's why the most effective one when we have the two immiscible liquids that have different densities, we shall use decantation techniques. So, what decantation? Decantation is a separation process involves carefully pouring off a liquid from mixture of liquid-liquid or liquid-solid after the denser one has settled to the bottom. It's a simple method that relies on gravity. Alright, next slide. So if you are in industry for separating oil and hydrosol, there has an order on method that we can use to separate these liquids. We have separating funnels, steam distillation go with extraction, and lastly the applications. For industry, main properties to consider is about high oil yields and efficiency. The second one must have cost effective in large scale production and last to minimize energy consumption and waste generation. In this case, the only safer option in industry is a steam distillation. Why? Because the production yield is a standard and stable depends on floral or plant. Basically, industry will use microwave assisted extraction, but steam distillation also widely used as the cost effective and equipment easy to maintain on large scale production. Next, what are the separation of essential oil and hydrosol in cosmetic application, which lab versus industry? Aspect for lab, use small batch in beaker separating funnel and manual decantation. Meanwhile, the industry one use decantation tanks and automated pipelines. The second one, its purpose for lab is purpose generally for sample testing, research and development. Meanwhile, industry use mass production of high purity essential oils. Its efficiency for lab may leave some mixture, but for industry will give more efficient and longer separation time. Control method, of course, industry the best one on automated level sensors due to the low energy but cost higher compared to the lab energy.
Alright, moving to the separation of oil spill applications. In the lab, we typically simulate an oil spill by mixing a known amount of oil and water in a beaker. The goal is to observe and evaluate the separation process. After allowing the mixture to settle, we transfer into a separating funnel or a large scale separator. Over time, the oil and water naturally separate into 2 layers due to their density difference. By opening the valve at the bottom, we can drain the denser water and then collect the oil layer. This simply but effective method helps us understand key principles such as immiscibility and density-based separation. Some important considerations at this scale include the selection of container, time for separation, and scale of the simulation. These factors help ensure a reliable and observable separation process. Now we're moving to the industrial scale. In large-scale oil spill recovery, we apply the same gravity-based separation principle. This process is known as gravity separation. What is gravity separation? As we can see on the right slide where oil spill happened in Gulf of Mexico, decantation principle are used for this case. Oil and water are allowed to settle in temporary holding tanks. Since oil is less dense, it naturally floats on the top of the water, making it easier to collect. In offshore scenarios, decantation principles are used as well. The oil-water mix is collected and stored, and buffers are added inside the tanks to reduce the layer is retained for recovery. The key consideration at this level include equipment design, control of flow rates, handling of emulsions, and regular maintenance for reliable operation. These factors are crucial for environmental compliance and efficiency in oil recovery.
Move on to the third application, which is centrifugation technique in pharmaceutical. Centrifugation is a mechanical process that uses centrifugal force by spinning the subject to separate components in a mixture based on their density.
In laboratory scale, we use large benchtop centrifuge. The sample is spun at high speed, and it creates centrifugation force that separate immiscible liquid based on their density. For the example, in TNT extraction, a chloroform and water mixture is spun to separate the TNT containing aqueous phase from the organic layer. So for the industrial scale, in industry, centrifugation is done in much more larger scale. The machine like this centrifuge is run continuously and can separate thousands of liters per hour. They are fully automated and widely used in pharmaceutical manufacturing, oil-water separation, and even in food processing. So let's compare the benchtop centrifuge and this centrifuge, which is benchtop centrifuge is used in the labs, and this centrifuge is used in the industry. So first one is centrifuge for using at lab, which is benchtop. Usually use small amount of sample. It's usually used for insulin extraction, and it use the tube for the sample. Put the sample. Then for the distant centrifuge is used in factories and industry. It means distant centrifuge can produce large amount of product within a short time. So this centrifuge is usually works continuously, and everything is more automatic compared to benchtop centrifuge. So in a lab centrifuge, it is small, manual, and used for testing only. But the industrial centrifuge is big, fast, and used for mass production. But both use the same principle, which is we spin the sample to separate the sample based on their density using centrifugal force. For the further understanding, you can refer the table of comparison below.
For the conclusion, in this study, there are two main techniques we choose, which are decantation and centrifugation. Two applications are used decantation techniques such as in essential oil and hydrolysis separation. And the second one is oil spill separation. Basically, oil and water were involved in these two applications. Descentation is a simple gravity-based method where the top layer of a less dense liquid, which is the oil, poured off and leaving the denser liquid behind. In essential oil and hydrosol separation application, this is often done manually in the laboratory using a separating funnel. In industrial, automated descentation system or settling tanks are used to handle large volumes. In oil spill separation application, the same concept was used. The mixture of oil and water is allowed to settle down and the oil layer carefully separated. In the laboratory, mechanical oil-water separator was used to separate oil from water based on the gravity and the density differences. While at industrial level, oil spill recovery involved large-scale technologies such as booms, skimmers, dispensers, and gravity separators. The next technique that we choose is centrifugation in immiscible liquids in pharmaceuticals application. Centrifugation, on the other hand, uses centrifugal force to separate liquids more quickly and efficiently, particularly when dealing with emulsified mixture or liquids with similar densities. In laboratories, benchtop centrifuges are used for small volumes, whereas industrial centrifuges such as destack and decenter types can operate continuously and automatically to handle large-scale separation in pharmaceutical, chemical, and food processing industries. Lastly, the study shows that while each separation technique is based on the same core principle, such as differences in liquid density, the choice of method depends on the scale, desired efficiency, and application context. Understanding and applying these separation techniques are appropriately enable effective purification, risk reduction, and product quality enhancement across various fields.